master's dissertation, Comparative Analysis of Electricity Consumption at Home through a Serious Score Perspective. 현웅채, Department of Electrical and Computer Engineering, The Graduate School, 성균관 University. Title of abstract: Machine learning is a modern field that has emerged as a new tool for data analytics in a distributed computing environment. There are several aspects at which machine learning has improved the processing capacity along with the effectiveness of analysis. In this paper, the electricity usage of the home is analyzed through K-means clustering algorithm for obtaining the optimal home usage electricity data point. The Davis-Burdon index and serious score finds the detailed optimal number of clusters in the K-means algorithms and present the application scenario of the machine learning clustering analytics. Machine learning is a state-of-the-art sub-project of artificial intelligence that is evolved for finding large-scale intelligent analytics in the distributed computing environment. In this paper, we perform comparative analytics onto dataset collected for the electricity usage of home based on the K-means clustering algorithm. Using comparison to a serious score with the ratio A/1 dataset, the performance evaluation shows that the comparison index is similar in the number of serious score even if datasets are smaller than before. Keywords: machine learning, K-means clustering. Big data analytics has simplified the complexity of large-scale dataset processing in a parallel distributed environment. Chapter 1: Introduction. Machine learning is an analyzing mechanism that fetches and identifies the matching patterns from existing datasets for your result formations. This paper discusses comparative analytics related to unsupervised learning algorithms, at which we compare the K-means clustering result with the ratio of half dataset to serious score result. We performed the analysis and came to a conclusion that Davis-Burdon index is not working smoothly in the scikit-learn library. So perform a check analysis for Kalinske-Harabaty index and the serious score along with the Davis-Burdon index and compare the result to each of them so to learn that when we reduce the dataset to a mentioned proportion, the resultant dataset shows half score than the traditional data score. Overview and motivation. In real life, household power consumption, diverse analytics, and electricity transformer. Transmission power can manage the period can estimate it, and each data using electricity consumption, it can be used for progressive taxation. Regional to regional demand, the forecasting, maintenance of power plant and facilities in the gas company or car company can estimate about the consumption for the via K-means algorithms and also can estimate via K-means algorithm and also can estimate about the gas consumption rate via K-means clustering and index. Paper 1. Content. Introduction. Machine learning is a subject of artificial intelligence that is used to develop algorithms and techniques for enabling the computers to run. It is used to train the computer for various aspects such as distinguish whether emails received are spam or not, data classification application, association rule identification, and character recognition. Machine learning includes a series of processes in which a computer looks up for similar patterns, generate a novel classification system, data analytics, and producing meaningful results. It is a kind of artificial intelligence that can be predicted based on the result. If it is supported only by analytics algorithms, machine learning is a step-by-step evolution process that leads from big data analytics to predict future actions toward making decisions on its own through past-run result. The key issues for processing a successful predictions model remains to be within increasing the probability and reducing the error, and said problems are resolved through enabling numerous interactive learnings. At the heart of the machine learning are representation and generalization, where expression is an evaluation of data and generalization is processing of future data. Unsupervised learning is a type of machine learning that is used primarily to determine how data is organized. Unlike supervised learning or reinforcement learning, this method does not give a target value for input values. Autonomous learning is closely related to the density estimation of statistics. This autonomous learning can summarize and describe the main characteristics of the data. An example of autonomous learning is clustering. In this paper, we use K-means clustering algorithm to measure the optimal number of clusters based on the Karas-Karabatic index and Shiller score, James Borger index, and then apply it to household electricity consumption analysis. Previous work, machine learning. Machine learning is like data mining, but it is different in predicting data based on learning attributes, mainly through training data. In addition to the three techniques, unsupervised learning, supervised learning, or reinforcement learning, various types of machine learning techniques such as semi-supervised learning and deep learning algorithms are developed and has been used. Clustering. Clustering is a method of data mining by defining a cluster of data considering the characteristics of given data and finding representative points that can represent the data group. A cluster is a group of data with similar characteristics. If the characteristics of the data are different, they must belong to different clusters. It is the main task of exploratory data mining and common techniques for statistical data analysis used in many fields, including pattern recognition, information retrieval, machine learning, and computer graphics, maximizing inter-cluster variance, minimizing the inner cluster variance. Note, however, that cluster should be distinguished from classification. Clustering is unsupervised learning without correct answers. In other words, we group similar objects without group information of each object. Classification, on the other hand, in supervised learning, when you carry out classification task, you will learn to predict the dependent variable. With the independent variable x of the data. Community feasibility assessment. Since clustering tasks are not correct, they cannot be evaluated as indicators, such as simple accuracy, as in a typical machine learning algorithms. As you can see in the example below, it is not easy to find the optimal number of clusters without the correct answers. Cluster analysis itself, it is not one specific algorithm, but a general task to be solved. It can be achieved by various algorithms that differ significantly in their understanding of what constitutes a cluster and how to efficiently find them. Popular notion of clusters includes groups with small distance between cluster members, dense areas of data space. Scikit-learn, in general, a learning problem considers a set of n samples of data and then tries to predict the properties of unknown data. If each sample is more than a single number of, for instance, a multi-dimensional entry, it is said to have several attributes of features. Supervised learning, in which the data comes with additional attributes that we want to predict this problem, can be either classification, self belong to two or more classes, and we want to learn from already labeled data on how to predict the classes of unlabeled data. An example of a classification program would be handwritten digit recognition, in which the aim is to assign each input vector to one of a finite number of discrete categories. Another way to think of classification is as discrete, as opposed to continuous form of supervised learning where one has a limited number of categories and for each of n samples provided, one if to try to label them with the correct categories or class. Scikit-learn is a machine learning platform in the middle range of superficial broad Python module. This package high-level language can easily high-level documentation and proper API suggested. Using UBSD license as academic commercially used. Source course documentation is downloaded from website. Supervised learning, unsupervised learning is main problems in insert in the second run. Generalized models, linear quadratic requirement analysis, kernel rigid regression, support vector machine, stochastic gradient descent model solution also inserted in the second run. Proposed approach. K-means algorithm is one of the clustering methods for divided. Divided is giving the data among the many partitions. For example, receive data object N. Divided data is input data divided. Data each group consisting of cluster below equation is a K-means algorithm when cluster consists of algorithm using cost function used. In other words, one of the data objects divided by the K group. Currently divided similarly, dissimilarly with reducting the cost function about it. And from this theory, each object similarly increase. Different group similarity will decrease. K-means algorithm is each centroid and each group data object times summations. From this function result, the data object group updated clustering progressed. How to be clustering inner weights, Kalinske-Karabaj index, Davis-Bard index, Dunn index, Shiller score. In this paper, evaluated via Kalinske-Karabaj index and Shiller score evaluated. From the cluster Kalinske-Karabaj index, SI, the cluster distributed average and cluster distributed ratio will give it to you. For this BK is a distributed matrix from each group. WK is a cluster distributed defined. N is the number of data. CQ data group in CQ is a cluster Q centroid. C is the E of the centroid and Q is the number of data number in cluster Q. Shiller score is the easy way to data I each data cluster in data's definition. I each data is not clustered inner and data definition. PI Shiller score equal to calculate them. From this calculate SI equal to that function. SI is close to 1 is the data, is correct this to each thing. Close to -1 cannot distributed cluster is distributed. From this paper, machine using the machine learning library scikit-learn in the household power consumption clustering. Household power consumption from the dataset downloaded from the University of California Irvine Machine Learning Data Repository, and then use it. This data set is via delimiter is divided. Global active power, global reactive power, voltage, global intensity is divided. Global active power and global reactive power, the XY axis experimented. Python library is Anaconda X3. K-means algorithm's key point is using data K clusters, reducing cluster distance. K-means algorithm input data, put the labels. Figure 1 is the before check Kalinske-Karabaj index and Shiller score execute K-means algorithm's result. Figure 1 to figure 11 are A/1 data K-means clustering result for household power consumption from UC Irvine repository and reduce the data A/1 times from original UCI machine learning data repository. After reduce each cluster distance, calculate each cluster Kalinske-Karabaj index. In increasing cluster, Kalinske-Karabaj index will decrease with the K ratio is to rate. Low estimate K this cluster partition will one more or non-electric consumption rate is very important. This one is the most important fact. Equal with the Kalinske-Karabaj index estimation, calculate Shiller score the cluster will increase the Shiller score will decrease with the K distributed or low factor with optimal K represented. From K-means cluster algorithms calculate the proper cluster, things is very important. From the data estimate Shiller score, the result is K-7 each cluster centroid and data prices Shiller score are 0.799 is the optimal score. From the former Kalinske-Karabaj index result are 5.60399 is the optimal result. Using this Cambridge algorithm, the fact is figure 11. From this Cambridge algorithm cluster 7, each group centroid and each centroid distance will be optimal value. From this result, each centroid can be divided. Household power consumption rate via clustering. Davis Bordern Index. If the ground truth levels are not known, the Davis Bordern Index second matrix Davis Bordern, then the Davis Bordern Index is defined as the 0 is the lowest score as possible. Score value closer to 0 indicate a better partition. But the problem is the algorithm does not attach it in the scikit-learn library and only explain it in the document page but cannot experiment easily. 3.2 Related work. Machine learning is a sub-project of artificial intelligence that is used to develop algorithms and techniques for enabling the computers to run. It is used to train the computer for various aspects such as distinguishing whether emails received are spam or not, data classification application, association rule identification, and character recognition. Machine learning includes a series of processes in which a computer looks up for eye-similar patterns, generate robust classification systems, data analytics, and producing meaningful results. It is a kind of artificial intelligence that can be predicted based on the result if it is supported only by analytics algorithms. Machine learning is a step-by-step evolution process that leads from big data analytics to predict future actions toward making decisions on its own through best-run result. The key issue for processing a successful prediction model remains to be within increasing the probability and reducing the error, and the said problems are resolved through enabling number iterative learnings. At the heart of machine learning are representation and generalization, where expression is an evolution of data, generalization is a processing of future data. Unsupervised learning is a type of machine learning that is used primarily to determine how data is organized, unlike supervised learning or reinforcement learning. This method does not give a target value for if values. Autonomous learning is closely related to density estimation of statistics. This autonomous learning can summarize and describe the main characteristics of the data. An example of autonomous learning is clustering. In this paper, we use the K-means algorithm to measure the optimal number of clusters based on the Karas-Karabatic index and Shiller score. This Bordern index and then apply it to household electricity consumption analysis. Summary. From this paper, household power consumption via K-means clustering use a library which is scikit-learn. Anaconda 3 open source personally can easily follow it because using BSD license to real works don't have difficulties to do that. Not only K-means algorithms, PCA algorithms, but also SVM algorithms, etc. Other machine learning algorithms clustering can also do it. From this result, in real life, households power consumption, diverse analytics, and electricity transformer transmission power management period can estimate it, and each data using electricity consumption, it can be used for prognostication, regional demand forecasting, maintenance of power plant and facilities can do it. In the gas, the company can estimate via K-means algorithms and also can estimate the gas consumption rate to via K-means clustering and index. Content introduction. Machine learning is analyzing mechanisms that fetches and identifies the matching patterns from existing datasets for newer result formations. This paper discusses comparative analytics related to unsupervised learning algorithms, in which we compare the K-means clustering result with the ratio of half data set to Shiller score result. We performed the analysis and came to the conclusion that Davis Bordern index is not working smoothly in the scikit-learning. So performed a check analysis for Karas-Karabatic index and Shiller score along with the Davis Bordern index and compared results to each of them, so to learn that when we reduce the dataset to a mentioned proportion, the resultant dataset shows half score than the traditional dataset score. related work. Machine learning is a field of artificial intelligence that is used to develop algorithms and techniques that enables computer to run. It is used to train the computer and to distinguish whether emails received are spam or not. And there are various applications such as data classification, associated role identification, and character recognition, which comply to the standard machine learning perspectives. It includes a series of processes in which a computer finds its own patterns, creates a new classification system, analyzes the data, and produces meaningful results. The successful predictions occurs with an increase in probability and decrease in the error issues. Machine learning enables to sort out the issues with various iterative learning. Among them, supervised learning is highly related to summarizing the learning method for reinforcement mechanisms. Clustering is a process of mining the dataset by defining a cluster of data that considers the characteristics of input and finds representative method to point out the data group. In this way, a cluster is a group of relevant data elements with similar characteristics. If the functions are not the same, the ingredients belong to contrast clusters. Clustering is unsupervised learning without accuracy in answers. In the same way, the objects having the same information are grouped together for similar elements. However, the classification is a way related to supervised learning. When you perform classification operations, the system will learn to predict the dependent variables with the independent variables of the data. Scikit-learn is a machine learning platform in the middle range of superficial broad Python module. This package high-level language cannot easily high-level documentation and proper API suggested. Using BSD license academically and commercially used. Source code documentation is downloaded from website. Supervised learning or unsupervised learning is many problems is inserted in the scikit-learn. Generalized models, linear and quadratic decrement analysis, corner rigid regressions, support vector machines, stochastic gradient descent models solutions also inserted in scikit-learn. Paper methodology. K-means algorithm is one of the clustering methods for divided is giving the data among the many partitions. For example, receive data object n. Divided data is input data divided kn. Data each group consisting of cluster below equation is the K-means algorithm when cluster consists of algorithm using cost function used. In other words, one of the data objects divided by the K group. Currently, the divided similarly is dissimilarly with reducing the cost function about it. And from the theory, can each object similarly increase, different groups similarly will decrease. K-means algorithms in each centroid and in each group data object times summations. From this function result, the data object group updated clustering progressed. Serial score is easy way to in data. Each data cluster in data's definition and each data is a clustered inner and data definition bi. Serial score si is equal to calculate that. From this, calculate si is equal to the function. Si is close to 1 is the data each data cluster to each thing. Close to -1 cannot distribute cluster distributed. From this paper, using the machine learning library, scikit-learn in the household power consumption clustering. Household power consumption from the dataset download from University of California Irvine Machine Learning Dataset Repository, and then use it. This dataset is via delimiters is divided. Global active power, global reactive power voltage, global intensity is divided. Global active power and global reactive power, the XY axis experimented. Python library is Anaconda 3 K-means algorithm. Key point is using data key clusters, reduce cluster distance. K-means algorithm input data, put the labels. Figure 1 is the before check Kaliskov index and serial score is cute. K-means algorithm result. Figure 1 to figure 11 are APA1 dataset K-means clustering result for household power consumptions from UC Irvine repository and reduce the dataset APA1 from the original UCI machine learning data repository. Figure 13. A for one dataset should score according to change of cluster number. From Cambridge algorithms, calculate the proper cluster. Seeing is very important. From the data estimate serial score, the result k equals 7. Each cluster centroid and the data prices serial score 0.799 is the optimal score. Even if the dataset is so small, but the A for one dataset k equals 7, each cluster centroid and data prices serial score 0.810 is the optimal score. From the Cambridge algorithm, cluster 7, so all dataset A for one dataset, each group centroid and each centroid distance will be optimal value. From this result, the dataset is decreased, but the Cambridge clusterings class vector space. Each dataset is decreased, but the Cambridge clusterings class vector space. Each optimal cluster is the same situation with before original dataset. Household power consumption rate via clustering. Summary. From the paper, household power consumption via Cambridge clustering. Use the library which is scikit-learn Anaconda 3 open source personally can easily follow it. And because using BSD license to real world don't have difficulties to do that. From this result, even if reduce the dataset A for 1, but the serial score and all the clustering result is the same as before. But the population will increase, it can show a clearer result for the classification and vector space. Large dataset to small dataset is clear to show to the specific result for the serial score, but the opposite side is not clearly allowed. Because of 4-dimension vector dataset from the experiment reduce the estimate time if received a huge dataset from the analysis. Chapter 5. Conclusion. His discussion approach to diverse aspects of Cambridge clustering applications. First time to try to reduce the Cambridge algorithm's time consumption, but next time I try to change my aspect to the how to reduce the time from large dataset. The approach is changed. These days, via machine learning algorithms can estimate about when changing the part lifespan from the result, or the part of experiment use the library scikit-learn Anaconda 3 open source can easily implement any environment. Because using BSD license can analyze diverse indexes from the first experiment. From a second experiment, if the dataset is huge, need time to analyze. How many centroid is a proper Cambridge cluster? At that time, can reduce time compared with A for one dataset but limited classification and vector space. From the experiment, reduce the estimated time if received huge dataset from analysis.